Our next set of questions is rather challenging, but we're more than capable of reaching a solution in each case. A bag contains only red counters, orange counters, yellow counters and white counters. A counter is picked at random from the bag. We know the probability of it being red is 0.36. And then the probability of it being orange is 4 times the probability of it being white. So let's go orange and then yellow and then white. So if we say the probability of being white is x, and the probability of being orange is 4x, and the probability of being yellow is 3 times the probability of being white, so 3x. Given that there are 18 yellow counters in the bag, work out how many red counters there are in the bag. Well, I know at some point I'm going to want to find the probability of yellow counters and then work with that. But I might not know exactly how to solve this. What I can do though is find x, and so that's going to be my initial starting point, and I know that the total probability of something being red or orange or yellow or white is 1. That is, if I do 0.36, add 4x, add 3x, add x, that must sum to 1. So 4x add 3x is 7x, add x is 8x, and then 0.36 I'm going to subtract from both sides to give me 8x is 0.64, and therefore x, if I divide both sides by 8, is 0.08. Probably in the exam I would check that on my calculator to make sure I hadn't made any silly errors. But that means I know that the probability of white is 0.08 and then yellow and orange are 3 and 4 times that respectively. So the probability of yellow is 3 times 0.08. Again, 0.24, but I might want to check that on my calculator just to be sure, 0.24. And I can think of 0.24 as 24 over 100. Or alternatively, I could use the value given on my calculator, which is 6 out of 25. Either is fine. But I know that there are 18 yellow counters in the bag. In other words, I need my numerator to be 18, because then it'll tell me 18 out of some amount, and that amount will be the total. Now this is why I've used 6 out of 25 here, because it's a bit easier to see what I need to do to get 6 out of 25 to have 18 in my numerator. I multiply by 3, and so I must also multiply my denominator by 3. I can do that with 24 over 100. I'm multiplying, or I can think of it more as dividing by 2 to get 12, and then multiplying by 1.5. So I'm effectively, what did I say? Dividing by 2 and multiplying by 1.5. So 1.5 over 2 gives me 3/4. So I'm multiplying by 3/4, and 3/4 of 100 is 75. So I know then there are 18 counters, and that probability of yellow is 18 out of 75, so there must be 75 counters in total. 75 counters in total. But that's not the question. That's not the question. The question is how many red counters are there, so I need to do 0.36, the probability of red, multiplied by 75, 0.36 multiplied by 75, and that gives me 27. And the fact that that's a nice round integer tells me that probably I've done the right thing here. Question 15. One day, Latif drives to visit his friend. On the way to his friend's house, he drives at 50 kilometers per hour. When he returns home, he takes a longer route that has better roads. On the return journey, he drives an extra 23 kilometers. His average speed is 6 kilometers per hour higher, so that's 56 kilometers per hour, and the journey takes an extra 15 minutes. Now, one thing I notice immediately is my speeds are in kilometers per hour, my time is in minutes. And all I'm going to write down in each part of the journey is my speed, my distance, and my time. Because I'm working with average speed, so I know average speed is total distance divided by total time. And if I call my distance d and my time t, and I want those both to be in hours, then my new distance, well, he drives an extra 23 kilometers, is d add 23. And it takes an extra 15 minutes, so t add 0.25, because I must be in hours. I now have 2 unknowns and 2 situations, so I want to generate 2 equations from those situations. As I say, average speed is total distance divided by total time, so 50 is d over t, and here 56 is d add 23 over t add 0.25. And I want to work out how long the return journey takes. In other words, I want to work out the value of t. So I'm going to rearrange this equation to make d the subject. D is equal to 50t. So I can sub it in here and eliminate d from that equation. So I get 56 is equal to, and then 50t add 23 over t add 0.25. I'm going to multiply by t add 0.25, so 56t, and then 0.25 times 56 is 14, so add 14 is equal to 50t add 23. I'm going to move over here because I don't encroach on my answer line. I'm going to subtract 50t from both sides, 6t. I'm going to subtract 14 from both sides equals 9. So t is 1.5 or 1.5 hours, but I want t add 0.25, the time the return journey takes. Might have written return down here so I didn't forget, which is 1.75 hours or 1 hour and 45 minutes. And that gives me my answer for another 4 marks. The third question asks me to prove that 0.38 with just the 8 recurring is 7 over 18. This is an algebraic proof. I'm always going to do the same thing. I'm going to take my recurring decimal and I'm going to call it x. So this is 0.3888 going on forever. And then my aim here is to make it so everything to the right of my decimal point cancels out when I do a subtraction. Now I could multiply x by 10, that gives me 3.8888 and so on. And that will get rid of all these recurring 8s, but I'll be left with a 3.5. I don't really like that in my fraction, so I'm also going to multiply by 100x, giving me 38.8888. Now, if I take this line and this line, I subtract one from the other, I'm left with just an integer on my right-hand side. So that's what I'm going to do. 2 subtract 1 is 90x is equal to 35. You must show all these things because it is a proof. I divide both sides by 90, x is 35 over 90. If I cancel by 5, I get 7 over 18, which is what they asked me to show. And that's quite a difficult set of questions, largely sorted just by us writing down some things that we know and reasoning out how we can get to a final answer, rather than knowing what to do immediately. And then a nice little algebraic proof at the end.